All right, everybody, welcome to the video here for lesson number 6 on the GCF and difference of two squares methods of factoring. So let's just jump right in here. So the first one here I've noticed is difference of two squares. I know that because I have a difference. 81 is a perfect square, and I have even exponents. So I have everything I need to do this. So we're going to do x squared plus 9 and x squared minus 9. Where do those numbers come from? I'm thinking what multiplies to itself to make x to the fourth, that's x squared, and what multiplies to itself to make 81. Then we have to ask ourselves, what can I still factor? So the first parenthesis definitely cannot be factored. The second one, however, can. I can multiply x times x to make x squared, and 3 times 3 to make 9. Notice I can't do that here because of the plus. We proved that in class. Next, we have 9k squared minus 49. It's the same thing. So we have 3k times itself makes 9k squared, plus 7, and 3k minus 7. Number 2 says factor over the integers. In this class, it has to say that, right? In Algebra 1, it did not because you only knew about integers, right? There will be some things here that we can do factoring-wise that are not just with integers, but that'll be for later on in the chapter. So first things first, we want to look for GCF, which is 3 and t to the fourth, which is going to leave you with 4t to the fourth minus 25. Why is the GCF t to the fourth? It's always the smaller of the two exponents when it's variables. If you think about it, this is like 8t, this is like 4t, so I can take 4 away from both. This is still factorable, however. So I can factor this to 2t plus 5 and 2t minus 5. All right. For number 3, I noticed that we have some common value here and here, right? So common expression. So we could factor that common expression out. It's still GCF factoring. Okay. So once we have that, we can then say, all right, let's factor what's left. Difference of two squares. Next one, we have a common value here. So because I have the common value there, I can factor out the common expression, and I'm going to be left with x squared minus 4y squared. It's still factorable. Subtraction, perfect squares, even exponents, all the things we're looking for. So we have x plus 2y and x minus 2y. Then number 4, explain why x squared plus 1 cannot be factored over the real numbers as x plus 1 and x minus 1. The reason why is solely because the last term times the last term creates the last term. So you could say 1 times negative 1 does not equal positive 1. That's why. You could show the whole multiplication out if you really wanted to, but that's not really what I wanted you to do here. You could show that this is x squared, negative x, positive x, and negative 1. These cancel, but this is not positive. There's no way of getting this to cancel with making this a positive value using real numbers. Okay? That's it. That's the video. Hopefully this helped. Make sure that you are studying up and starting to look over your notes for your quiz coming up soon. All right? Thanks. Have a good night.